Hi everyone, and welcome back to the Learn to Code by Writing Space Invaders course. In our last lesson, we managed to get different types of aliens on the screen and make them animate as they walk around left, right, and coming down. So it's about time we actually had a go at shooting them. We've got some missiles already on the screen, but they're not yet actually hitting any aliens and killing them. So that's what we're going to be working on in today's lesson. So let's get straight into it. So our last lesson was lesson 17. So let's load that in and save it as lesson 18 and into our code and just change that again. Okay, so we're back to where we were last time. So if I run the code, we can see that we now have our aliens coming across. They're walking and they're animating. We have different types of aliens, but when we shoot them, then of course our bullets have no effect. So really what we need to work on in this lesson is something called collision detection. So that as a bullet travels up the screen and it then hits an alien, our system can monitor that and then take the appropriate action. So if we consider an alien object and a bullet object, and they're approaching each other, we need to simplify it so we can actually start doing some calculations on whether they've overlapped or not. And the way we do that is to consider them as two boxes, and we actually call these bounding boxes, where the box defines the actual area of that object that can be hit. So our code now needs to work out if these two boxes are actually overlapping. If they overlap, then we've got a collision. So our software needs to know a few values regarding these boxes. We need to have a position, and our positions have always been for the top left corner. We also then need to have a width and a height for the box, which will let us work out where all the edges are. So let's take a closer look at these edges to see if we can work out a strategy to calculate if they are actually overlapping or not. So let's start by checking if they're overlapping horizontally, in other words in the left and right positions. And for that we need to look at the left and right hand edges of both objects. So in this situation, our objects are overlapping if the left hand edge of our bullet is to the left of the right hand edge of our alien. And we must also then have the right hand edge of our bullet to the right of the left hand edge of our alien. If both of those conditions are met, then our objects are overlapping in the horizontal. And we can test this out in different situations. So here the bullet is just hitting the right hand edge of the alien. But again, if we look at the edges, the left hand edge of the bullet is still to the left of the right hand edge of the alien, and the right hand edge of the bullet is still to the right of the left hand edge of the alien. And if we then look at a bullet hitting on the right hand edge of the alien, we'll see that these exact same conditions are met. But if we now consider a bullet missing the alien to the left, we'll see that the condition that isn't met now is that the right hand edge of the bullet is no longer to the right of the left hand edge of the alien. It's actually on the right of it, which gives us our miss. And if we then consider a bullet going past on the right of the alien, we'll see the condition that now that's not met is that the left hand edge of our bullet is now to the right of the right hand edge of the alien. So that gives us our horizontal overlapping. We also need to do the same then for vertical. And if we get both a horizontal and vertical overlap, well, that's a collision and we've actually hit the alien. So let's have a go at putting this into code then. So what we're going to do is we're going to create a new function, and we're going to create that down the very bottom of our code listing. And this function is going to tell us if two objects have hit each other. So we're going to write a function here called check collision. It's going to take some arguments which we're going to have to think about in a second, but let's just finish off our end statement there. This function, we need to give it two things to check for. So at the moment we're looking at our player bullet and an alien. But we're also going to eventually have to have a look at our alien bullets and our player ship and so on. So we need to write a function which is going to be able to handle any type of objects coming in and then work out if those two objects have hit each other. So we're going to use what's known as some object-oriented features, and we're going to look at something called an interface. And we're going to build that into our function. So as we go through, I'll explain obviously what that means. So to begin with then, our collision function is going to need to be sent in two objects that we want to test. So let's just call them object 1 and object 2. And let me just go into a smaller font size to begin with, okay? So we now have our function. We're going to be passing it two objects. And those objects could be different things. So sometimes we'll be passing in a player bullet, an alien bullet, or the player ship, and so on. What we have to make sure now is that our function is able to handle any object we send it. And the way we do that is to make sure that the objects we send it have a very similar set of variables inside it. And this is what we call our interface. So we're going to say that our object must have a position variable inside it, and that position variable will also have a position.x and a position.y. We're then going to say that our object must have a width parameter, and it must also have a height parameter. Just correct my spelling there. Okay. So what we're defining here, we're defining a particular set of variables and parameters that must exist inside the object we send in. So we know already that when we've been doing any of our bullet objects and our alien objects, we've always set a position inside it, and that position has always had an X value and a Y value. So we've been very consistent about the way we've done that. And you can see here why we've been consistent, because that helps us then, if we're passing objects around, if they obey the same sort of structure, then we can write functions that can just assume that that structure is the way it is and work with it. So we obviously now need to make sure that any object where we're going to do collision detection on will have a width, which will tell us how wide this bounding box is, and then a height, which will tell us how high this bounding box is. So let's go up and make sure that our objects have those features in them. If we start by looking at our bullets then, our player bullets, let's go to our initialize player bullets function, which is here. And this is where we set up our array full of bullets. So we can see here that we are filling up our array with these bullet objects which are defined here. So we already have our position, and that's what we've been using in all of our objects. But we now need to include a height, and that's going to be equal to its length, which is 5, which we just defined down here. And then we need to put in a width, which is going to be 1, because it's 1 pixel wide. So that makes sure then that our player bullet object conforms to this interface, or we say it implements an interface. So we have a position, a height, and a width, and that's what our collision detection software is expecting to find inside the object. So let's now have a look at our aliens. So we initialize our aliens over here, and this is where we then create that alien object which has got all that information in it. So again, we've already got the position of our alien, so we need a height of our alien and our sprites are all 8 by 8 pixels, so our width will also be equal to 8. And that's now made sure that our aliens again implement this idea of the interface as well. So let's go down to our collision detection code and see if we can get that worked out. So we now know that we have these objects being passed in, and we're going to have to compare their top and bottom edges and their left and right edges to see if they're overlapping so that we have a collision. So the first thing we need to do is to work out where those edges are. And the easy way then is to do some local variables which will capture that information. So let's say that we have our object 1 left-hand edge. So we know that that's simply given by object 1's position dot x. So it's x and y coordinates, so the left-hand edge will be at this x coordinate. We then need to look at its right-hand edge. So object 1 right. So we know that's going to be the object 1 dot position dot x, and we're going to have to add on something to that. And again, we might think that it's just simply the width of that. And again, that would be object 1 dot width. Object 1 dot width. But if we think about that, that's not quite right. So say we have our object, and I'm just going to number pixels here. So let's just say we had a number of pixels here. So if we have our alien, we know our alien is 8 pixels wide. So if we put our alien at pixel position number 1, we can see here that our left-hand edge is also going to be at position number 1, because we're going to pick up on that x parameter. We know that the width of the alien is 8 pixels, but if we simply add that on to x, okay, so we'll have our value of 1 plus 8, which will actually take us to 9. That's not actually where our right-hand edge is. Our right-hand edge is actually at pixel position 8. So we actually need to back this off by 1. And that means that then when we come in here, our left-hand edge is given by our x position, which in our example would be 1. Our right-hand edge then is our width, so our x position plus our width, but take away 1 to make sure that we actually hit that particular pixel value. Okay? And again, we'll have to do a similar thing for our height as well. So let's look at the top and bottom then. So object 1 top, we're going to set that equal to object 1 dot position dot y, which is our y value, and then our another local variable, our object 1 bottom, and we're going to set that to object 1 dot position dot y, and we're going to add on object 1 dot height, and we're going to take away 1 from that. So that then lets us define all the edges of our object 1 coming in. So we're going to have to do exactly the same thing then for our object 2. So let me just highlight all of that, and if we go across here, oh, can't get to that bit. So let me just bring these down 1. So like that. Let me just bring that down 1 so that we can see what's going on. And now I can highlight all of that. I can copy it, and I can come back over here, and I can paste it in. And we now have our second copy. So again, this now wants to be exactly the same, but now with object 2. And everything's going to be exactly the same here, just with a 2. And 2, and the last one. Okay. So we now have a set of local variables which define our object 1 left, right, top and bottom, and our object 2 left, right, top and bottom. We now need to do our overlap check. So we're going to be doing an if statement, and we know that we're going to be doing a number of checks in this. So our first check is that our object 1 left, we know that that has to be less than our object 2 right. So the left hand edge of object 1 has to be to the left of the object 2's right position. And then we have the other ones. So I'm just going to put them directly underneath each other here. So our object 1 dot right hand position, object 1 right, now that's a local variable, our object 1 right needs to be greater than our object 2 left. And object 1 top must be less than object 2 bottom. And our last one then is our object 1 bottom must be greater than our object 2 top. So if all of those conditions are met, then we have a collision. So we return true, else it's a miss, so we return false. And that then is the end of our collision detection. So again, just recapping then, we're sending in two objects. Those objects have to implement this idea of an interface. In other words, they will have a position object inside them with an X and a Y position. They will have a width variable and a height variable. And if they have those, then our code here can work out all the edges of the bounding boxes, do our comparison, and then either return a true for a hit or false for a miss. Now that we can detect if two objects have collided, we need to write some code which will check all of our bullets and alien collisions. So let's create a new function which is going to check our bullet collisions. Pardon me. And that will be an end for that function there. Check our bullet collisions. So this is going to check if any of our bullets have hit aliens. And we need to actually run that then from within our main code. So let's just copy that block of that name there. And go back up to our tick function. And in our tick function then, so we initialize our game, we move our player ship, we check our firing, we move the bullets, we move the aliens. So after we've repositioned all of our bullets and aliens, at that point we'll want to check if any of them have been hit by our bullets. So that will give us that block of code then. So let's go back down to our check bullet collisions function. Okay, so this function then, it's going to have to check each bullet and then check each bullet against each alien. That way we can then see if any bullet has hit any alien. So we're going to have to use our for loops and for loops inside for loops. If we do get an alien being hit, we will then need to kill that alien. So remember we have an alien dot alive variable. So that tells the system whether that alien is alive or not. And we'll also then have to kill the bullet so it doesn't just carry on travelling up and killing loads more aliens. We already have a lot of the code written for this. So if we go to our draw function, so if we go to our draw bullets function, so draw player bullets function, we'll see there that we already have the code that loops through each of the bullets. We have code that tells us whether a particular bullet has been fired or not. So again, we'll have to only check collisions with bullets that have been fired. And remember, inside our loop, we are able to access this particular bullet by using that expression there, the player bullets, and then square brackets, the bullet one, because that's our bullet counter. So that block of code lets us step through every single bullet and checking if it's active, and then doing something in here if it finds a bullet which has been fired. If we go to our draw aliens function, again we'll get most of our code. So again we have our for loop inside a for loop. So this is going round every row and column, and that then lets us pick out each individual alien in our array. This line, of course, then checks if that alien is actually alive, and then we do something inside there. So our code's going to be our for loop for our bullets. Then these for loops are going to be inside that bullet for loop. So we're going to have a loop inside a loop inside a loop. This loop will be inside once we know that the bullet is actually active. And inside this bit here, so the very inner part where we are down to a single alien and we have a single bullet, that's where we're going to do that collision detection between the two objects and decide whether we need to kill the alien and bullet or whether there's no collision at all. So that's the basic structure for our new function, our check bullet collision function. I'd like you to have a go at doing that. So again, if you need to go back over my description just previously, just rewind and have a listen to that. But see if you can implement that in here then. I'm going to give you a 5-second countdown on the video, and then I'll go through it with you. So have a go and see you in a second. Hi again. If you've managed to get that working, well done. If not, just follow me through here and we'll go through it step by step. So we're going to do every single bullet and every single alien for every single bullet. So let's first of all go and grab some of that code. So again, we said a lot of it's already been done in previous functions. So if we go to our draw player bullets function, again, we know that this block of code here sets a loop going and then checks if this bullet's active, and then we can do something about it. So let's copy that and go back down to our check bullet collisions. And if we paste that in there, okay, so we're now doing for every bullet in our bullet array. If this bullet active, then we're going to have to check it against the aliens. So that is the end of our if bullet active if statement, and that is the end of our for each bullet loop. Okay, again, so it's very handy if as soon as you create these structures, put the matching end in and just note which one it is so that we don't get lost, because we're now going to be doing loops inside loops inside loops and ifs inside ifs and so on. So that gets us now looping through every single active bullet. We now want to loop through inside that, we loop through every alien. So if we go to our draw aliens function, we already have the basic structure here. So it goes through every row, every column, which then picks out every single alien. We check if that alien's alive, and then we do something. So let's have a go with this. Let's copy that and go back down to our check bullet collisions function. And so in here, we want to paste that in, and let's just tidy that up so we can get all the matching bits sorted out. And that will then be our if statement stepped in one more. Okay, so we have our if alien row column, so that gives us our individual alien. So if this particular alien we're looking at is alive, then we need to do our checking for the collision. So that there's the end if alien alive bit. We then have another end, so that matches with our column for loop, and then our other end which is the for loop for our row. For row. And that's a for loop end, and that's a column bit. So we now have our basic structure to go through everything. So our outer loop is going to go through every single bullet. If this particular bullet is active, then we're going to stay with that one bullet, but we're going to check it against every single alien and every single alien that's alive. Okay, so at this point in our code, inside this if statement, we've now got an active bullet, which is denoted by this expression, so our player bullets array, and then the bullet element, because we're using bullet as our counter. We then have our alien, so from our aliens array, using the row and our column counter, and that gives us a single alien. So at this point here, we have our two objects that we want to decide if they have collided or not. So to make this a bit more readable, I'm going to use a little flag variable. It's not entirely necessary, but it will make it just a bit more readable. So I'm going to create a local variable, and that's going to tell me if bullet has hit alien. And I'm going to initially set that to false, because of course we haven't got a hit at that point. So this bullet has hit alien flag. Once we get into this bit of the system, I want to go and check if we have got the hit. So I'm going to set my variable equal to this idea of the check collision. I'm pretty sure we called it check collision, didn't we? Check collision, yep. So check collision, and we know that that function needs two objects applied to it. So I'm just going to come down here and put the close bracket here, and then in this area here I'm going to put the objects that we're going to be detecting for. So our first object is our player bullet that we're currently working with, and that's given by that expression, and we take a new line for there. And then the particular alien that we're looking at is that one, and we now have our collision detection. So from our outermost for loop, that will give us the particular bullet that we're looking at, and then our innermost for loop will give us the alien in a specific row and column. And that way we'll start off looking at bullet 1, then do bullet 1 against every single alien, then we'll go to bullet 2 against every single alien, and so on. So in that way we'll cover every single possibility. Right? So at this point now, we've created a variable which is either going to be true or false depending on whether this bullet has hit this alien. So if our bullet has hit alien, so if this particular flag variable is true, then this point here we have detected a hit, and that is the end of our if statement. So if we get a hit, this is where we now have to make sure that we take the appropriate action. So we know that once an alien's been hit, he is killed. So we have to set his alive flag. We have to assign a value of false. So that will now kill off our alien. And remember, in all of our draw and routines and move routines, we had always been checking this alive flag to see whether it was true or false. And if it was false, we simply just ignore this alien so it never gets redrawn. We also now need to make sure that this player bullet, so this player bullet given by this expression, he has an active flag which tells us whether that particular bullet is still being fired up the screen. But of course, as soon as it hits one alien, it needs to be killed off so that it doesn't carry on up and shooting loads and loads of aliens. And that should now turn that bullet off. So hopefully that is everything done. So we're checking every single bullet, every single alien. If we get a hit, we're killing the alien and then turning off the bullet. And then it will be ready to be refired by our firing mechanism. So let's take the plunge and give that a go. So I'm going to do Control R and see what happens. So everything's still working up there. Let's see if we can fire a bullet. I'll do a miss to begin with, just to make sure the bullet still fires, and we can still fire bullets. And let's see if we can hit an alien now. And there we go. We have now got the ability to shoot the aliens. And you can see there that it is working quite well. If it misses the aliens, it goes up past them. Okay, so if you managed to get that, well done. If you didn't manage to do that last little bit of programming, then make sure you follow through there. Again, we're getting to quite complicated structures now, where we're having, you can see here we've got a 4 with an if inside it, then another nested 4 with a nested 4 with a nested if with a nested if. So you can see how we're working away, and hopefully you'll see as well this idea of keeping your code tidy and making sure you work with this indentation idea. You can start to see now a better idea of how the code's structured just by looking at the listing. Okay, and again, it's starting to get even more important now that as soon as you put an if statement in, you put the matching end statement and label it so that you know which end goes with which if, and same with which end goes with which for. As our code gets more complicated in its structure, keeping your code listing tidy does become more and more important. Otherwise you start to get lost, and you'll never be able to match up which end goes with which bit and so on. So keep on top of that as you're going along. Well, that wraps it up for this lesson. So we now have our alien array. We are able to fire bullets at it, and we are able to kill aliens. But at the moment then, obviously they are just simply dying off by just disappearing off the screen. We want to make that a little bit better. So that's what we're going to have a look at in the next lesson, and we'll actually see if we can animate some explosion effects on them to make it look a bit better. So make sure that you save your work. So I'm just going to do Control S to save my work, and I will see you in lesson number 19. Bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.